Alright, so for video number 2 in this series of 4, we have a U5000. So let's open this up and see what's wrong with this one. It's got labeled as 7401, but it's not, it's a U5000. So if we look here, it is clearly a U5000. Here's the selection jumper and everything. So, and you can see here on the side, maybe you can't. It doesn't have the correct sticker. But yeah, this is a U5000. This is the jumper selectable standard and medium resolution U5000, and it even has the vertical sweep mod over here, which is what this is. It should be attached. Normally you can see that there's a hole here for this retainer, and normally there's a hole in the side right there, and it normally just goes right here with a screw and a nut. I may try and do that, but yeah, that's what's there. So there is a jumper here. So you can see, I mentioned in the previous video on the 7400, the test point on this chassis is right here, this 30 volt reference. This is that 30 volt reference, the same as the 25 or 30 volt reference that was right here on the 7400 for the vertical IC. So the way this works is there's a jumper. When you have this set to standard resolution, you have to have this plugged in. This is supposed to be plugged in for standard resolution, just like that. There's only one wire here, the white wire, so you plug this connector on for the white wire. This has to be plugged in for a vertical sweep mod for your 15 kilohertz. When you have this jumpered over to 25 kilohertz for medium resolution, this is not supposed to be plugged in. You can damage the vertical IC if this is plugged in while you're selected to 25 kilohertz. So that is a red flag to me immediately, because this was plugged in and it's set to 25 kilohertz. If you look here, you can see that there's actually a selection, 15 kilohertz for standard res, 25 for medium. So with this being plugged in, that's awful scary to me with what's going on here. But he's got this marked as, or labeled as a K7400. It's actually a U5000. So again, we have horizontal collapse. I'm sorry, it's been a long day. Vertical collapse, center line, no deflection. Well, I assume it's vertical collapse because he changed out the vertical IC again. So it's labeled incorrectly. It's actually U5000, but it says vertical collapse. So again, just like the last one, it's the same thing. It's a different location. You can see it's kind of set up differently on the 7400. I have a spare donor chassis here. I'll show you. On the on the K7400, R303 was up and down here, and D302 was right underneath it. Well, on the U5000, D302 is kind of still in the same position here, but R303 is horizontally mounted. Instead of being up and down here, it's actually left and right. So this is R303 here, but D302 is still here. So we have D302, R303, and then we still have our D603 right here, D603. And again, this one has this, oh, I forgot what this is called already. Like I say, it's been a long day. The insulator, there's an insulator installed that doesn't need to be there, which doesn't affect anything, but it doesn't need to be there. So I'm going to take that back out. But again, so we'll test those three components. You'll see that this one doesn't have R402 in it like the 7400 does. So we just check these three components and see if we get lucky. I'm just going to take his word for it that it's got a horizontal collapse. There's no real reason to test. Look at this, is awful loosey-goosey. I may fix that before we even turn it on. You can see this here going back and forth. I don't like that, so we'll fix that before we turn it on. But in the meantime, I'll assume that it actually is vertical collapse. That he wouldn't have changed. It's odd that the last chassis had the G2 wire had fallen off. This one has a broken focus wire. The focus wire is out of the, so have to fix that too. And of course, like all these damn things, the neck board, the neck transistors are all floppy, so I'll have to fix that. Let's see how bad they are. Oh, whoops. Oh yeah, that's no good. Well, I did not have to fix this on the 7400 in the last video because they were all good. There wasn't even any heat discoloration, but this is very bad. And look at that, all of the traces. I'm sure it probably works, but I'm gonna have to fix this. This is no good, man. All of them. Well, that'll be secondary. I'll probably turn it on and see if it works, then I'll fix this later, because I don't need this to see if it's collapsed. But I will have to probably fix Q703 here. But in the meantime, let's set this stuff aside. And just like the last time, we'll test R303, D302, and D603. Let's get our meter in place here. Let's zoom in a bit just so we can see what's going on. Okay, D302 is good. R303 again should be 1.2 something. Oh, 500k ohm. Well, that's not good. Yeah, 580k ohm. Well, I think we found it. That was easy. Let's go to D603. That's good. Well, hopefully that's the issue. Let's take it out of the circuit. Oh man, I don't know what's going on here. I don't know what this is. And the header pins for the video selector are not cracked, but they're on their way. They're awful oxidized, and some thin solder will take care of that as well. And this has got some kind of jumper thing going on. So someone's done some work to this, probably in an attempt to try and fix this. I gotta wait for my iron to heat up. In the meantime, I'll get a cold snack here. Okay. This has spent some time with some spider work. Some spiders have had their way here. The vertical IC solder work doesn't look too bad. There's a lifted trace here a little bit, but no solder bridges. Decent solder work. Yeah, not too bad. Everything else looks fairly decent. So while we're under here, let's pull R303 out, one leg of it anyway, and looks like it's this one. Yep. And we'll test it out of circuit. And out of circuit it reads open. Huh, so nice. So the 7400 in the previous video had an open R402, and this one has an open R303. Nice. Okay, hopefully this is a quick and easy repair. Let's take it out completely and test it again. Alright, while we have this upside down, let's suck out the solder off of those pads. Alrighty. Now where did my resistor go? There it is. Alright. So we'll test our leads here again. Leads are good, and then we'll test our resistor. 100% open. Well, I mean, I don't know if that's the problem, but that is a problem. So do we have one that I can steal here? No, R303 is gone from here, but it's supposed to be a 1.2 ohm resistor. So let me see if I can find one. Actually, I have, I think, 2 or 3 donor U5000s that I was able to rob that R402 from the previous video in the K7400. So let me go down and see if I can grab one of those and steal this resistor off of there. So one moment. Okay, so prepare for visual carnage here. This is a U5000 that was absolutely demolished and destroyed in shipping, and this is not repairable. Technically it is, but I'm not even going to bother to attempt to try. So fortunately, we have an R303 on this one. Let's see what it reads. 1.3, fantastic. Let's steal that sucker off of there. Get it in our other one over here and do the quick reflow on the stuff that needs reflowed and fire it up, see what we get. Alright. Get this in here. Okay. And we'll test it on the bottom side here. 4.3 because it's hot. The resistor is hot, so you'll see as it cools down, it'll go down 3.4, 3.3, 3.2. So, all right, I think we're in business. While we have this upside down, we're going to have to reflow these. On the U5000, these video selector header pins they get very hot, and it's notorious that they develop cracked solder joints. So if you ever come across a U5000 or you have a U5000 and you haven't reflowed these pads, get on the ball and get these reflowed, because that's something that I would highly recommend. Get away from there. There you go. Alright. I'm actually surprised that none of these are cracked yet, because they're on their way. They haven't quite got there yet. Ideally, you'd want to remove the existing solder off of these and then put new solder on, but this is just fine. I definitely don't want to bridge anything here. Well, kind of doing this upside down from how I should be doing it. There we go. And if this fixes the problem, I'll come back through here after this is over, or after we're done, I should say, done troubleshooting and testing and verifying, and I'll come through and do a full, complete, proper reflow. I do that always before I send these back to the people who send them to me. Alright, so that's done. I'm going to hit this one real quick. And the vertical IC solder looks okay. Let's check our continuity. before we go here. Alright, so we don't have any open traces or pads. Check that one more time. Okay, that should be everything as far as we need to do for the bottom side. And let's move this back over to 15. If I can. Oh, man. There we go. That's been on 25 for quite a while. Alright, so we're on 15. This is not supposed to be hooked up for... Oh, I'm sorry. This is supposed to be hooked up for 15. And not supposed to be hooked up for 25. I actually want to verify that because it's on the actual U5000 tube. There's a little sticker that denotes how to hook that up, and I think I'm correct. I think it has to be hooked up for 15 and should not be hooked up for 25. But I need to verify that because I don't want to tell you incorrectly, and I certainly don't want to be incorrect as well. I'm just going off of memory here. Oh, I forgot. We got to do Q703 here. Let's test this. Oh my God! Yeah, I'm glad I looked at that. Look at this. A very common issue. Look at this. That is bad. So I can't really scrape off the trace because it's completely all the way lifted, all the way to the next pad. So in all instances it probably would have worked, but I'm gonna have to add a jumper here. Do I have? I do. This should work. Okay. Let's do this just for now, and I'll fix it later a better way if I'm able to. All right. Okay, that should work for now. Okay, that should be good enough for at least now. Yeah, it doesn't even move anymore. It doesn't even move anymore, so that should be okay for now. Then when they put, some of these have a heat sink and some of them don't. I mean, in my experience, I've never known these to even get hot, but they have a heat sink on there for a reason. But all it does is cause things like that to happen. But as you can see now, it's not loose anymore, and as I wiggle it, it doesn't lift the pads anymore. So that should be good. Okay, I'm confident about that. We didn't create any bridges, but let's actually verify that it's good. Here we go. Here, and I believe, do I have that backwards? Yep, 0.6 and 0.6. Okay, so that's good. Alrighty, I'm going to verify that this should be hooked up for 15. And using the test pattern generator, we'll test 15 and 25. But the important thing about this is to just make sure it doesn't have collapse. Make sure it's working and replacing our 303 fixed our problems. That's the first thing to test. And we'll go ahead and make sure we got our 30 volts here on the side. So we'll get our meter hooked up to test that when we power it on. And let's check this one more time before we do, just to make sure we have good connection on everything. Yeah, there's no broken traces, they're all hooked up. So in theory it should work. I'll have to fix this more permanently. But I've already got videos on that. It won't be part of this video. This video is just to fix the horizontal. I'm sorry, I did it again. This video is just to fix the vertical collapse and touch up whatever needs touched up to get it powered up and work reliably. And this kind of stuff I'll fix later off camera, because I already have videos on how to do this. You know, I may even just fix it and show you the aftermath of the repair. I think I'll do that. I'll go ahead and fix it and do all the work off camera and show you how it looks afterward. And then we'll test it one more time after that. But for now, let's go ahead and just get it hooked up and see what happens. One moment. So I went down and got the U5000 that I'm going to be using for testing, the tube and yoke anyway. This is the chassis that belongs to this tube, and this is the one we're working on. But I wanted to show this diagram here, and you can see it's upside down, but this is the chassis side, and this here's the jumper. This jumper here. So you can see that it's supposed to be hooked up for 15 kilohertz, and the 25 is not. So you know, you have to imagine this wire is the pin on the chassis. You can see it lines up with the 15. It does not with 25. So it has to be hooked up for 15, and it should not be hooked up for 25. And the fact that this was hooked up with 25 selected, that's kind of scary to me. So hopefully that this R303 being bad is the only issue, but we're about to find out. So I'm going to get this off of here and slave this one in, turn it on, and we'll see what happens. Okay, so while hooking all this up, I forgot that I didn't fix the focus wire. As I was hooking the neck board up, I noticed it hanging there. I forgot to fix that, but I did fix it before we did anything. I have not powered it up yet, just trust me. Like I say, I like to share the knowledge with you guys. I don't like to fake videos or do stuff behind the scenes and pretend like, oh, I did this and that. No, it's all real. So I forgot to hook this up, and I just found it as I was hooking the neck board up and got it fixed before we did anything. So I got this sitting here. So this is the vertical sweep mod again. I have it plugged in because it needs to be hooked up for the 15 kilohertz, which is what I have it selected to. We're going to test our standard res first. So we're hooked up to, or set the standard res on the tester. So we'll turn it on, and oh, I forgot to hook up power. It's always something. Last time I think it was the video input, and this time it was power. All right. So okay, here we go. What's going to happen? 1, 2, 3. Okay, powered on. Do we have full deflection? Don't have any, well, partial deflection. Is it, it's jumping around. Do we have a cold solder joint or something? Oh, then it just went full deflection there. Oh, and something is cooking. Something is cooking. Yes. We had some deflection and it just went kabooey. I can smell it. Let's turn this off. And interesting. I don't see anything, or I don't see any smoke or anything, but it's some, you saw there, it went complete collapse. And yeah, that's not good. So let's take it back off and see what died. So that smell is coming from the area of the vertical IC. Here, let's give it a sniff. Can you smell it? Yeah, it's coming from the vertical IC area. And if you remember before, we checked our D603. Only now our D603 is shorted. Shorted this way, and shorted this way. So now we have to take it out of the circuit and see if the vertical IC is causing it to reach shorted, or if it in fact is shorted. So I mean, I think what I'll have to do here is I'll take the vertical IC out, because it may, with R303 having been bad, it may have done something else I don't know about. So I'm going to pull the vertical IC, but we can test to see if it's shorted. The only one that should be to ground, I think, is this one. But let's see if anything is actually shorted. There should only be one pin that reached to ground, and I think it's this one. But let's see here. That's not good. See, that's 30 ohms. So that's not good. 51 ohms, that's not good. That's our ground right there. There's our ground. So we have three pins. 24 ohms, 4. So this pin here is not supposed to be grounded. It's reading 4 ohms. If we go to ohms, 3.6 ohms. Now if we grab our other chassis here that is working, and we do the same thing, there should only be one pin to ground. So we'll go back to ground here, right there, and it's good ground. So open, 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 open. There's our ground. Nothing. So we have 4 pins on the other one reading to ground. I think 2 of them are because of the diode, but something just roasted our vertical IC. Now I don't know if there's something else that's wrong, or if it got roasted, if it was already roasted and it took out the diode, or if the diode was bad. I don't know what the circumstance of series of events was, but I think what I'm going to do is take the vertical IC out, replace the diode, and see if we get our 30 volt reference. If we do, then I'll put another vertical IC in and see where we're at from there. So let's take the diode out and just see if the diode is actually bad in circuit, or I'm sorry, out of circuit. If it's good out of circuit, then it's definitely the vertical IC that's faulty. So we'll grab that diode out of there. I believe it is this leg here. It's not happy about flowing, so we're going to add some new solder to it. Then we're going to get it out of there. That's usually the best way when you have a stubborn joint. Flow some new solder on there, and you'll get that puppy out lickety split. Okay, so there's our diode removed from the circuit. And if we test it now, it's good. So our diode's good. So now we have a 100% confirmed shorted vertical IC. So let's get it removed, just for the sake of quickness. I'll cut away here. I'll solder the diode back in, and we'll get the vertical IC out, and I'll come right back, and then we'll hook it up and see if I get my 30 volt reference. So I got the vertical IC removed. I got D603 reinstalled or resoldered in, and I went through and tested all the pads to ground, and nothing is shorted to ground except the pad that's supposed to be off the ground. So nothing else is shorted to ground that is inducing its short onto the vertical IC that I can find anyway. So with that all done, let's see what we get. I took off this wire. This wire was actually running from this solder joint all the way over to this solder joint, which just happens to be our pin for that 30 volt reference. And the reason it was there is because the board is broken here. You can see the board is broken. There's a giant chunk out of this trace. So I sanded off the trace with my fiberglass pen, and the game plan here, oh here it is to solder, just do this the way it should be done. Solder that on there and cut this there, and there you go, like new. I mean, not only will that work better than this is ungodly. So yeah, let's check continuity here to make sure that that's good. From this point to over here, yep. And you can see here, if we do this again, the only pad that's shorted, 1, 2, 3, 4, it should be this one. Yep. Nothing, 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 nothing. So there's nothing else shorted, inducing a short onto the vertical IC. So now what I want to do is just see if we get our, I'm going to hook this up and just see if we get our 30 volt reference. If we do, I'll put a new vertical IC in and see what we get from that. Because a lot of times, if we do this, I didn't mention it on the previous video with the 7400, but if we put, if the 30 volt reference is here, or over here, wherever it's at, depending on if it's 7400 or whatever, if you have your 25 or 30 volt reference and you've changed out your IC chip and verified there's nothing wrong with the circuitry and you still have vertical collapse, a lot of times U701 can be the culprit on that. So we may have a bad U701. As a matter of fact, let's just see if we have anything shorted on U701 just to see, because I'm curious here. Let's go back to ground. Yeah, it's dead short to ground. Nope, U701's not shorted, so, well, let's just see if we get our 30 volt reference, because we still should get it regardless of whether the IC is in or not. Let's just see what happens. So let me put everything back together here. I took everything apart just so I can easily move this around and work on it. We'll get all of this back together here. Alright, this is always a bear. There it is. Never want to forget to hook up your remote board. That would be disastrous. The consequences could be disastrous. I think that's it. So let's get it back on the tube and see if we get our 30 volt reference. If we do, I'll put a new vertical IC in and see what that does. So stand by a moment. Okay, all set up, turned on, ready to go. Let's see what happens. Nothing. We're all hooked up. Power, video signal, it's on. We're set up to read 30 volt reference, turn it on. Nothing. Well, I just assumed it would run without the vertical IC. Maybe it won't. Let's install one and see what happens. I mean, worst case scenario, the last one didn't blow immediately, so we can at least let it run long enough to see if we get a difference on the image, but I guess it won't run without one. You learn something new every day. Let's fire it back up with one installed, see what happens then. Well, new vertical IC is installed. We both learned together that obviously it doesn't boot up without, or power up without a vertical IC installed. I would have imagined that it would have, but apparently it doesn't. So I got a new one installed. Let's turn it on, and that makes sure it at least turns on. And because we had something obviously burning, and I could smell it burning very, very quickly, I went ahead and hooked up our meter to make sure our B plus isn't like way out of adjustment, because I want to make sure that it's closer to 117 or 118. Like the last one should be 117. So if our B plus is way out of whack, that could account for some of the problems we're having, and the fact that I have a burning smell. So obviously it was working, but the burning smell to me is disconcerting. So I have, you test your B plus, there's a post right here on the U5000. Let's see if I take this off here, you can see it. It's right here, and it says vid B plus. Can I focus? Come on. It won't focus on it. There it is. Vid B plus. That post is where you check your B plus at. So let's get that plugged in for the neck board and hook this back up. Let's zoom out. Sorry about that. Hook this back up. Okay, we're hooked up on that. I lost my connection here for the positive. Okay, sorry about that. Okay, so we have our positive hooked up to read our B plus, negative is hooked up to the frame, our replacement voltage regulator, I'm sorry, vertical IC is installed. So let's see, A, does it even power up, and B, what our B plus is at. Yes, it powers up. 100, holy shit, back off this goes. 140. Yeah, that needs to be fixed pronto. And I don't know if I'll be able to do so because it is glued in place. We may have to replace it. Sometimes I can take these cutters and physically cut the glue and then I'll free up the pot. I'll probably have to try that. So let me try that and see if I can adjust it, because we got to get that to 117 PDQ. That's our first goal here, and then we'll see where we're at from there, because with 140 volts something is burning up and I don't want to damage anything else, because I was able to get it to power up again. So let's see what happens if I'm able to get that adjusted properly. So stand by one moment. Well, I was able to successfully change it out. This is robbed from a donor chassis, and this is the original. It basically just disintegrated into 3 pieces as soon as I desoldered it, so it was definitely bad. However, it's a 1 k ohm variable resistor, or 1 k ohm potentiometer, and I had to put in a 2 k ohm potentiometer, because even at all the way up at 1 k, this was 0.998, even at 1 k it was 124 volts. So I couldn't go any lower, so I had to put a 2 k ohm resistor in there and go to like 0.750 volts, I'm sorry, 0.750 ohms, and once I did, I was able to successfully get this to go to 117. There you go. However, I still have vertical collapse, and that burning smell coming from the chassis is coming from this thing. This thing is getting like white hot and just smoking. But we still have our vertical collapse. Yep, and this thing just is smoking. So that's what the smell was. That's where the smoke was coming from. It was this thing is just getting like white hot after about 30 seconds. So we're still at 170. So we're good there. And we got collapse, and yeah, this, you can see the smoke coming off of it. Holy shit. Turning it off. It is smoking. Look at this. Yeah. So this blanking circuit mod is bad. Now, I don't know if it's a cap, or I'm going to have to trace this out and see what's going on. But yeah, I got to turn this stupid fan back on. Whew, man, I just wanted to do that for demonstration purposes. But so there's something going on with this blanking circuit that's causing this collapse. I don't know what it is. We'll have to figure it out. At least we got our B plus set correctly and got that figured out. So we'll have to troubleshoot this further. So that's what I'll do. And when I come back, we'll see if I have it solved. And I'll explain what happened. So one moment. Alright guys, so it's the next day, and this thing has just been kicking my butt all up and down the block and back. And I found some issues, but we still have collapse. So initially, when we fired this up, we know that the vertical IC shorted. We tested it, and I think there were 3 legs that were actually shorted to ground. And one of those legs was pin 1, the very first pin on the left. If we zoom in here. Okay, yeah, the very first pin on the left is shorted right now. It's shorted dead right to the frame, right to the base, I guess, if you will. So there are, I think there's two other pins that are shorted that shouldn't be. So we know that was an issue. The problem is pin 1 is the 15 volt reference. I actually used my good U5000 and fired it up and did some voltage checks on the actual pins on the bottom with the vertical IC. So here's a quick reference of what pins should read what if you ever have to troubleshoot this. Pin 1 should be 15 volts. Now we know pin 2 and pin 9 are 25 volt reference, which we fixed by replacing the open R303. That brought back our 25 volt reference. When we did that, the vertical IC we found out was shorted, and this resistor started smoking. So I think it was still shorting even after we replaced it with this one. I can't recall, but either way, it's not smoking anymore. And the reason for that was because the 15 volt rail was shorted. Pin 1 at the vertical IC had nothing. It was completely dead. And there's actually a test pin right here, like your B+. There's another little test pin here for your 15 volt rail, and it was 0 as well. And it was 0 because this Q601 was shorted. And that's part of the 15 volt rail as well. So I don't know if this took out the IC or the IC took out that, but I don't know the series of events. But we were missing 15 volts, and it was shorted, the Q601. So I replaced Q601 with the good one from a donor chassis, and that brought my 15 volt rail back. So now I went through and tested all the voltages and all the pins, and they correspond to what the good U5000 reads. 15 volts, 25, 3.8, 7, 5 is the ground, so nothing there, 8 volts, 9 volts, 4.4, 25, and 2.0 volts. So all of those voltages are within a volt or two of what they should be. So since I have all of my correct voltages now, the chassis itself should be good because we're supplying everything to the IC that it needs to have, and it's still collapsed. I'll show you here. Let me turn this on. And you see my 15 volt rail is actually at 13.7, and it's climbing. It eventually settles out around 14.01, so it's close enough to 15 to make the system work. It's not really that big of a deal, but it should work. Everything is solid the way it should be. And as we can see here, well, I gotta turn this on, sorry. I forget every time. Yeah, still collapsed. So, turn this back off. Oops, sorry. So, at that point, I thought maybe there's some capacitors that are bad. So, I changed out all the capacitors in this area, and it turns out that 2 of them had the wrong rating. This one here was 35 2200, and it goes in this position. It should have been 35 1500. So someone had the wrong rating of cap in there, which it shouldn't have been that big of a deal, but that was the wrong rating. And then this location here should have been, let's see, 2.2 microfarad, and this one was 4.7 microfarad. So there were 2 caps with the wrong rating. It shouldn't have made that big of a difference. I changed them out anyway. I also changed out the other 3 here, this one, and this one, and there's another one, I think, back over here. But I changed out 5 caps, thinking that maybe the caps in this area were bad. Did nothing. We saw we're still collapsed. So at this point, with having all our correct voltages, I'm fairly certain that we just simply have a bad vertical IC. Because this one that I used, this one here was the original one that we know was dead shorted and killing the 15 volt rail. You know, in union with this bad transistor. So this transistor, or this vertical IC I have in here came out of here. This one here was the bad one out of the 7400 in the video prior to this one that I fixed, and then there were 2 remaining that I was told may work or may not work. So I threw it in there thinking that maybe it'll work, but I don't think that it's good. Oops. I don't think it's good. So I actually have a little box here of spare parts from donor chassis that ended up being used for other purposes or thrown away or what have you. I robbed some parts before I did that, and I actually have a couple of vertical ICs in here. Here's one, and then I have another one chilling out down there, right there. So I'm going to put in, these are known good parts. I'm going to take this one out and put this known good one in, and hopefully it works. I'm confident that it will, or at least get better, because I've got all my correct voltages. So you can use this as a reference in the future if you're troubleshooting this actual problem. You can check to make sure your voltage or your vertical IC has your correct voltages. These are what they should read: 15, 25, 3.8, 7, 0, 8, 9, 4.4, 25, and 2.0. It should be within a volt or so of all these readings, but I am reading all of this correctly on this IC, and we're not smoking anymore. So I think the problem lies with simply a bad vertical IC. So after finding the bad Q01, getting my 15 volts back, replacing the R303, getting my 25 volts back, and everything else reading correctly, let's put this in and see if it fixes our problem. So stand by, let me get that changed out, and we'll see if we're lucky. Well, I got the new vertical IC installed out of my little test box of extra parts that are known working. This is the one I just took out that we originally replaced the shorted one with. This guy here. This came out of this tube, which I was under the impression they were working, but I don't think that they were. Because, like I say, I got all my voltages. If all my voltages are correct and present, and we still have vertical collapse, it has to be the vertical IC. The problem is if it's not. This is a known good one. If this still has collapse, I don't know what to do. I'm going to have to probably throw the towel in on this one, because I spent hours, I think maybe like 6 hours yesterday, and an hour and a half this morning, give or take, working on this thing, and I just have to throw the towel in because I'm at my wit's end. With all the voltages being correct, if this doesn't, and a known good IC, if this doesn't fix it, I don't know what to do. So let's cross our fingers and hopefully we are successful. We're set to medium resolution, so we do not want to have our sweep mod installed or hooked up. Let's make sure it doesn't short anything. Let's turn this on, and, well, fingers crossed. 1, 2, 3. Okay, it came on. This is an old and tired tube, so it may take a while for it to come on. I've rejuvenated it already. It's still very tired. No line yet. Oh my God. Oh, I'm speechless. You've got to be kidding me. This whole time. Ugh. I spent all this time checking every resistor, every diode, every capacitor, replacing stuff that I thought was bad. I did find that bad Q601 that was killing the 15 volt reference circuit, but that was caused by this shorted vertical IC. Oh man, I can't believe it. It's not set right. I hope I can. I hope I can adjust it. Let's see, height. Oh yes, hot dog. Awesome. Width. Width is as wide as it goes. That's odd. Still got roughly this much on the side and that much on the side. That's odd. I probably can adjust the width coil, but I should be able to adjust that more. We'll have to check our B+. Man, RGB. Yeah, there's RGB. The red gun's pretty weak. It's about 50% weaker than the green and blue, but that's a tube issue. I have the same problem on the other tubes that I test with this U5000 tube, or other chassis I test with the 5000 tube. So if we do contrast, right there is about as much as contrast can be. Brightness, roughly there. I mean, that's not bad, but you can see how much weaker the red is compared to green and blue, and that's the tube, not the chassis. Well, I wonder if we can turn our contrast and brightness all the way down and turn up our flyback here just a bit, and then try again. Nope, right about there is your maximum. And brightness is there. So that's as good as I can make it look on this tube, but I'm just blown away with all this effort. It turns out that it was a bad vertical IC this whole time. well, a bad replacement. So see how we have some, well, we got raster lines. See the raster lines here, but my flyback is, maybe you can't. Yeah, they're there. You can, there you go. Now you can see it. My raster lines are too high. I gotta turn this down a bit. There we go. Now they're gone. We still got that bleed, so let's turn our contrast down again. And there we go. Alright, let's test our 15 kilohertz. So let's turn this off. And for 15 we want to have this plugged in. And our resistor is nice and toasty, but it's not letting off smoke anymore. So let's move our jumper connector from standard to medium. Oh, I'm sorry, medium to standard. We were on medium. Let's go medium to standard. Okay, got that switched over. That guy right there. And let's move this, turn this off, move it over to standard, turn it back on. We got this plugged in. So let's make sure standard works. Try again here. Please, please, just do me a favor this one time. Yes! Each position, vertical size, where you at? There you are. And position, outstanding. Oh man. Oh, every so often you come across one that just makes you want to beat your head against the wall, but don't give up. You'll see it through, and it'll work out for you in the end. So, living proof here. Man, what a hassle. All right, I'll let it run for a couple hours. We know that both our resolutions are good. Let me see if I can adjust the width. We're a bit, let's see here. Something's going on here on the side. You can see that. Let's move our H position over. There we go. Something's going on there. I think that might be a cap issue. This has been recapped, but these caps look pretty substandard. And again, I found one that was two of them that were the complete wrong rating. So the customer didn't send me any caps. I'm not going to cap it because it wasn't a request. It doesn't need it in theory. But let's see if we can adjust the H width here. We'll put our plastic adjustment tool in here. Never use a metal one. And well, I'm moving it, but it's not doing anything. Ever so slightly. I'll get it figured out. But anyway, there you have it, guys. A repaired working U5000, both resolutions. I guess in summary, we had an open R303 that was killing our 25 volt reference. We had a jumper wire installed to jumper the 25 volts to this pin right here because the chassis was damaged, so we fixed that. We had two caps that were the wrong rating. Got those fixed and changed out other three that I think were probably okay. We had a shorted Q601 that was killing our 15 volt reference, which was caused by a completely shorted voltage regulator or the other way around. We had a bad B plus pot that was keeping it from being able to go down to 117. And then we had a bad replacement. We had a shorted IC and a bad IC, a bad replacement from this stock of 3 that was sent to me. So, yeah, there's all the junk that was wrong with this thing. And still running, looks great. But I wonder if my width issue might have to do with B+. I'm going to cut away here and come back and make sure our B+ is still good. And then I'll get all the rework done on the neck tube, or I'm sorry, on the neck tube, on the neck board, and I'll show that off, and then we'll test it one more time and we'll check our B+. So hang on one second. So actually here, as I think about this, you can see that the black line, I'm back on medium resolution, and the black line's not there. Our B plus is supposed to be 117, but 118.3 is actually okay. It's close enough, I'm not going to mess with it. But if we scroll through here and just look at, let's say, see the green and the blue and the white. Now if we turn this off, switch it over to standard, and switch our resolution connector again back to 15, and always remember to plug this in or you'll have you could damage the vertical IC. That may be what happened this whole time, was this was left out, I can't say, but this has to be plugged in for 15 kilohertz or you'll have a squished image and it'll damage the IC. It has to be hooked up for 15 and unhooked for 25. So let's turn this back on. We're on standard. So now if I turn this on, I'll have to shift the image again here, H position back over this way. But I think that I have a flyback issue. This black, see the black bleeding over this way? I think that's a flyback problem. If I scroll through to, see, there's my green screen and my blue. This black line on the side, I'm 99% sure that's a flyback problem. So I actually have a new flyback. I'm going to put this in and see if it fixes that. So I'm going to tear this all down, do the neckboard rework, and install this new flyback and see if that takes care of this black line. I'll bet you that it does. So stay tuned here for a second and we'll see what happens. And just like that, it's all fixed and ready to go. I got all the reflow work done on the entire main chassis. I also got this installed correctly with the screw and the nut through the heat sink, so this is secure, it's safe and not touching anything, and it won't flop around and short something out. And we all know how the jumper works. So this is all complete. I got the flyback replaced. Here is the original one that I suspect is bad, and I have two other ones that I robbed from other boards. So I had two spare U5000 flybacks that are known working, but I don't have any new ones. So I'm just going to slave in this other one from a different U5000 just to see if it affects that black bar. If it doesn't, I'll kind of have to see if I can figure out why that is. Maybe it's a cap issue. Probably have to end up doing all the caps again. But we'll see if that works. So I put another flyback in. It's a known good one, and we'll see if it affects that black bar. But it is not new. It is used. And the neck board, I was able to get all fixed up. You can see the heat sinks are now nice and evenly spaced. They're flat against the board. They won't rock around. The resistors are secure and reflowed. They're evenly spaced so they don't induce heat onto the next one and cause it to get hotter than it should normally. And I used my alternate method of doing this as opposed to running the jumpers. Normally you would see me run the jumpers from pad to pad. But on this instance what I did was the pads were all intact. They weren't, even though they were lifted and moving around, they weren't broken, and they were completely intact, and they weren't cut or damaged. So all I did was just use the super glue method. I super glued down. I took all the transistors and heat sinks and everything out, and I super glued the traces back down as best as they could be, and waited for it to dry. And then I put the transistors back in and cleaned it all up. I still needs better cleaning, but I cleaned it up as best as I could for the time. I ran out of alcohol, so I'll take care of that. But they're nice and secure now. They don't move around. They are rock solid. So everything on that is fixed. And that's another method you can use, is a super glue method as opposed to running the jumpers. If your traces are intact and good, they just lifted, you can use the super glue to fix that problem. So that's what I did here. So our neck board's good to go. Everything should be ready to power up, and we'll get it all on the tube and turn it on, see if it affects. Okay, we're all ready to go. Hopefully our black line is gone, because if it's not, I don't know what to do. This chassis has just been a nightmare. And with everything else that was going on with it, I went ahead and installed one of the nicer, newer, beefier, more reliable HOTs in there as well, because I don't want that becoming a possibility of a problem in the future. So I went ahead and put the nicer, newer, beefier one in, so that was done as well. And of course we put that replacement flyback in, which is used, but I'm hoping that it works better than this one. Because something else I noticed is that you don't hear the high voltage energized, and you don't hear the crackle down, so it's not bleeding off the high voltage, and you don't hear the high voltage energizing. Obviously it was working, but it's just odd you don't hear any of the energizing of the high voltage like you normally do when these power up. So I think maybe this flyback was on its last leg and going out. So hopefully we hear our high voltage power up, we hear it, and hopefully our black line is gone and we get everything else working the way that it's supposed to. So I wanted to mention we got the different HOT in there with the replacement flyback at the same time. So let's get this turned on. We're still set to standard resolution. And let me turn my fan off because it's kind of loud here. Alright, let's see if this works. Fingers crossed. Yes! We heard the high voltage that time. And again, this is an old tired tube and it's been off for, you know, half hour or so while I've been doing this, so it'll take a while to turn on. So hopefully we get the image. Hey, we get the image. Look at that. Is our black line gone? I don't know. I need to shift it over. Let's see, H position. Of course, our contrast is too high. Everything's different with that new flyback, so let's turn this down. Our brightness is too high. Let's do roughly there. That's good. Contrast is still too high. I gotta shift the H position over. Do we have our black line? Slightly, but not until it folds over. I'm still gonna call that okay. Let's put our screen roughly centered. And let's scroll through. Well, no more black line. At least it's better. Let's go to our white screen here. There's our white screen. And width. Hey, I have full width now. Look at that. Now I have full width. It even goes past the side and no black line. So that the replacement flyback fixed our width problem, and it appears to have fixed our black lines. So, hot dog. We also have our high voltage sound when we turn it on. So that flyback was definitely on its way out. Well, hot diggity and shazam. It appears that we now have a fully functional U5000. Oh yeah. Let's shrink our width now a little bit and move our H position to even it out, and there you go. Vertical size is a bit too high, so let's bring that down. Well, there you go. Fully functional, nice square image, working U5000. Not without much toil and gnashing of teeth, I'll tell you. With that, it looks like with everything else wrong with this chassis, the flyback was also on its way out. Also faulty. So let's switch over to medium res just to object that one more time. Turn the chassis off. Well, I don't hear it crackle down. There could be something wrong with the bleeder circuit, but I don't want to dive into that right now, so we're still going to call this repaired. So let's go to medium resolution. We'll swap our connector. Okay, set that back in place. Alright, and we want to disconnect our vertical sweep mod. Turn this on, and let's see if our medium resolution works. Well, again, I didn't hear the high voltage crackle up that time because it didn't bleed off. Well, I'm not going to worry too much about it because it is working, so I don't want to have to mess with that headache. Hey, look at that. We got medium resolution as well. So let's move our H position over. And holy cow, let's turn our contrast down. And our brightness is all the way... our brightness is all the way down. That's odd. Still looks like that. I wonder what's going on here. Why are we overly green? Brightness, contrast down. Let's turn our flyback back down here. There we go. That's better. Still kind of... something's going on there. Contrast. Okay, there we go. Just... you got to get this stuff tweaked just right. Yeah, we'll go right there, and our red is too high. That's our problem. Turn our red down a bit. There we go. Green. Yeah, that's not bad. Again, this tube is, the red in this tube is weak, but there we go. Yeah, awesome. So there you have it, guys. One big headache. If I had any hair left, I'd pull it out. So we had all the previously failed components I mentioned, and on top of all that, we also had a bad flyback. So just, I tell you, this was one of the most frustrating repairs I've ever had to do. So I appreciate you guys sticking with this long video here, and stay tuned for the next 2 monitors that are part of this lot of 4 that were sent to me, 2K7000s. Those should be much easier than this. And I appreciate it. Thanks for watching. Like, share, and subscribe, and we'll see you on the next 2 videos. Our image, see if our black bar is gone, and we'll see how it looks. So stand by one moment.